now try to do it. Let's go to your week number 6, lab 1. Okay, over there you will see we got the distance table there. It's the same exercise. It's now 1.2. It's now number 2. Okay, can we just go to week 6, lab 1? Let's create a new class over there. Okay, right click, new, and class. Let's call this matrix operations. Okay. And with a main method. Okay, let's now, because we know that we're going to read inputs from the user about the dimensions and also entries. So let's declare the scanner. Scanner input is assigned to new. Let's make sure we import that. Okay. Scanner system.int. Okay, now let's ask the user, first of all, how many rows for M1? So we're going to ask them how many rows, how many columns for M1 and M2, right? So in some way, this is a little bit more complicated than your assignment 5. System.out.println. Okay, enter the number of rows of M1. Okay, integer NR1. So I'll just say the number of row for matrix 1, NR1. Okay, that's my naming convention. Okay, NR1 is assigned to input.nextInt. And let's also put input.nextLine just in case. Okay, let's make the assumption that the user is going to behave. So they will give us some positive dimension. Okay, let's assume that. Okay, can we just copy this block? And then let's now do also the columns. The number of columns of M1. And then let's MC1, number of columns for matrix 1. Okay. So now let's say up to this point, we know about the dimensions for matrix 1. So now we want to prompt the user for NR1 multiply NC1 times. For example, if they say it's 3 by 4, we're going to ask them 12 times. If that's 2 by 5, it's going to be 10 times. Okay? Prompt the user for NR1 multiply NR NC1 times. Okay. So now let's do that quickly. So now you can say for, let's do a nested loop. Okay. Integer R is assigned to 0, R less than NR1, R plus plus. Okay. R for row. And for integer C is assigned to 0, C less than NC1, and C plus plus. And of course, let's create a matrix first. I forgot. Let's create a matrix. So we can say integer. Let's assume it's integer matrix. And then let's call the M1 is assigned to new integer NR1 and C1. Be very careful. Don't swap the order. It's going to do something completely different. Okay. Now we can assign that very carefully. Okay. Now first of all, for each one of them, we're going to say system.out.println. Okay, now you can say enter a value for, okay, let me just say print. So we can be a little bit pretty printing it. System.out.println. We want to print out N1 R plus, okay, open, close and open, and then C. Okay, like that. And put a value for this. Okay, you can put a colon after that. And after that, let's read the input. Integer value is assigned to input.nextInt. And then we can say input.nextLine. And then assign that. And 1 at R at C is assigned to value. Okay, so far not too difficult, right? You're just trying to go R and C, all the combinations. After this, we're going to print out what M1 is, and then we'll test. So now we can say system.out.println. Okay, this is the M1 you just typed. And why don't we just do another nested for loop? And you can say for integer, r is assigned to 0, r is less than nr1, r plus plus. Okay. For integer c is assigned to 0, c less than nc1, c plus plus. And then we can say system.out. So now we're handling the same row, out.print. So now we can print it out. We can say M1, R, and C. Let's say we can just have a space, we can have a tab, doesn't matter. We can have a tab if you like. Okay, after that, we know that for every row, this is at the end of the row, we're gonna print out a new line. System.out. Okay, oh, sorry, not this. You can say at the end of row R, print a new line. Okay, let's test it before we copy and paste for the matrix tutor. Now, enter the number of rows of M1. What about 3 by 4? 3 by 4. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, that's what you have. Right? Makes sense. It goes row by row and column by column. Any questions up to now? Hopefully you have no questions. Okay, so this is just about M1. We're going to do the same for M2. So let's do copy and paste. Okay? But if you do copy and paste, be careful. You got to rename the variables very carefully. So I'll show you. Okay? Let's now do the following. Can we just copy from here, enter the number of rows of M1? Copy that all the way to over here. Like that. Okay? So now let me put a separator here. Okay? Let's now do M2. I just copy that. You can see that's a separator. Okay? So now enter the number of rows of M2. So NR2. Enter the number of columns of N2. Oops. Of N2. And then NC2. N2 should be equal to NR2, NC2. Now, R is assigned to 0 and NR2. And let's change the comment as well. It should be NR2 multiply NC2. So make sure you change NR2 here, NC2 here. Enter a value for M2 at R and C value, and then here this should be M2, right? Be careful, go line by line, very carefully. And then we print it out, N2 over here, R less than NR2, C less than NC2, and then N2 over here, R and C, and then we're done. Okay, that's about matrix number 2. Let's try. Let's try something where the two matrices are of different dimensions to make sure we're doing the right thing. Okay? Let's try something very simple. Let's say for M1 is 2 by 2. 2 by 2. 1, 2, 3, 4. That's okay. What about for M2? Let's say 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, seems to be okay. So now we get M1 and M2. So now we are not in the tolerance. We can decide whether we can do addition, subtraction, or multiplication. Depends. Okay, we will do it whenever it's applicable. So when can we do addition and subtraction? We can do addition and subtraction if dimensions of M1 and M2 match exactly. Okay, that's what we have. So we're gonna say if it is the case that NR1 is equal to NR2, NC1 is equal to NC2, if both are true, then we can do addition and subtraction. For the multiplication, we're gonna have other conditions for this. Okay. So now we can say this: if NR1 is equal to NR2 and NC1 is equal to NC2. In this case, we can do both. Okay. Now we have to have two resulting matrices. One represents the addition, the second one represents the subtraction, right? Why don't we create two matrices? And the resulting matrices will have this exactly the same dimension as the blue on the board, right? If you have 2 by 3 and 2 by 3, you also get 2 by 3. Okay, the same. And also the same for subtraction. Now let's call this integer. Let's say, I'll say add. How about that? Add new integer nr1 and nr2. Also nc1. It doesn't matter if I use nr1 or nc1 here. It doesn't matter since they're equal anyway. Doesn't matter. Okay, nr1, nc1. And let's also do for subtract. I'll call it minus. Okay, the same. So now I can do them together. Okay, because I know the way we do subtraction and addition are exactly the same. Just go to the corresponding slots and do it. Okay, let's see how we can do it. So the way to think about it is we're going to go over the slots in the resulting matrix one by one, row by row, column by column, and see how we can compute the corresponding values given a combination of R and C. Okay. Let's see how we can do that. You can say for integer R0, R less than NR1, R plus plus. For integer C is assigned to 0, C less than NC1, C plus plus. Okay, like that. So now over here, I can fill in the two matrices at the same time. Okay, addition at R and C is going to be something, and the minus at R and C is going to be something else. It's going to be very similar. For example, if I want to calculate what's N3, if I want to calculate what's at 0, 0, it's going to be N1, 0, 0 plus N2, 0, 0. Right? On the other hand, if I want to know what's minus 0, 0, that would be N1, 0, 0 minus N2, 0, 0. Okay? Basically the same idea. Okay? That's why we can do them both at the same time. N1 R C plus N2 R C. For this one here, N1 R C, but with minus N2 R C. So one is multiplication, the other one is subtraction. Okay. Now we printed both out. Okay, let me be a little bit lazy here. Can I just copy the code over here? Okay, can I just copy that? Okay. And then after this for loop here, I'm gonna say this. N1 plus N2 is the following. I'm gonna do NR1 NC1 over here. And then I'm gonna do this. I'm gonna say at RC. That's everything. That's the only thing I gotta change. Okay, that's N1 plus M2. I will double check. What about N1 minus M2? Just print out the other one. N1 minus M2. NR1, NC1, and then now just refer to another matrix. Okay, plus and minus. Right? Now try. Let's say we got exactly the one we got on the board. Let's say 2 by 3 and 2 by 3. 2 by 3, 1, 2, 3, 4, 5, 6, and 1. And the second matrix also 2 by 3. 7, 8, 9, 10, 11, 12. Okay, n1 plus n2 is this, right? Let's see if we got it right. n1 plus n2. I think that's right, right? I think that's right. Yeah, somehow the way I count here is different. You can put it on the board, so it's easier to see, just to convince you. Right? You can see it's going to be 8, 10, 12, and then 14, 16, and then 18. Yeah, I think that's right. Any question about addition and subtraction? No? Let's do multiplication quickly. Okay? So now the constraint for multiplication would be, since we know this here is nr1, this is nc1, this is nr2, this is nc2. We can only do multiplication if nc1 is equal to nr2. Okay? That's the only circumstance under which you can do multiplication. Let's have that check and then do it. Okay? It's going to be triple nested loop. Okay? It's going to be fun. Okay, so here we have, over here, so we can do multiplication of m1 and m2 if nc1 matches nr2. Okay? Okay, let's do it. And then we have if nc1 is equal to nr2. That means we can do multiplication. Otherwise, we cannot. Oh, by the way, so let's add something quickly. So you can see here, we say if this is the case, we can do addition and subtraction, right? If it is not, else. So we cannot do addition and subtraction. Okay, and here similarly, we'll say else. System.out print line. We cannot do multiplication. Okay, let's now see how we do multiplication. Again, we are trying to apply the similar way of doing things. First of all, let's think about this. If I try to multiply, I know that nc1 is equal to nr2. The resulting matrix is going to have the following dimension. It's going to have the row corresponding to nr1. So that's going to be the dimension for the new matrix. nr1, and here that will be nc2. That's the resulting dimension. Let's do that first, okay, before we do anything else. So now we can do integer, that two-dimensional array. Let's say I'll call it M3. How about that? That's for multiplication. It's assigned to new integer, so it's going to be nr1, nc2. Be careful. Okay, it's very important to get this right. Okay, you guys, nr1 multiplied by nc2 matrix. So now the idea is we're going to go over row by row, column by column of n3, and you see what should this value here correspond to the corresponding row and column of m1 and m2 and do the corresponding calculation, right? That's what you can do. So here we say filled in n3, row by row, column by column. Okay, let's do that. Okay, let's do row by row and column by column. We can say for integer I is assigned to 0, I less than nr1. If you are not so comfortable about using these, you can simply say, since we already created n3, I less than n3.length. That's also fine. I plus plus. Oh, sorry. I want to use r. Okay, let's be consistent. Okay, nested loop. Integer c is assigned to 0, and c less than n3 at r dot length. C++. So now, what do we do? Let's make it a little bit more general. Okay? You kind of understand this example here. What about in general? Let's say this is one matrix. This is M1, NR1, NC1. Multiply. To multiply, you know that this part must be NC1, and this part can be NC2. Right? So this part they match. Now we're going to have this, something like this. This is going to be a matrix of the following dimension. It's going to be NR1, NC2. Right? Somewhere in the middle, we have this RC. I'm going to use a different color here. Let's say over here. Let's say this one is N3, R, and C. Okay? So now what should we do? We should go to row number R and column number C. Row number R in N1. And column number C is guaranteed. This row here and the column here, they are of same length. Guaranteed by the constraint that NC1 is equal to the NR2, right? Over here. Now we just do the sum of products of the two. Okay? That's all we do. You can see this one is going to be R, and then it's going to be M1, R, 0, M1, R, 1, all the way to M1, R, NC1 minus 1. Right? From column 0 up to this column minus 1. And this one here is going to be N2. So we have row number 0, and the column would be C. Row number 1, the column remains to be C, and all the way to, it's going to be N2. We have NC1 minus 1, and then we have C. Make sense? Okay. It's not too much about Java. Now it's just about math. Right? It's not about Java. Right? Once you understand math well, translating to Java is not too difficult. But of course, if you've got trouble, you should come to me for help. Okay? So now, how do we do that? Basically, we're going to run another for loop to somehow to say, based on the R and C, I'm going to run the for loop, which is going to go over 0, 1, all the way to NC minus 1. Here also, 0, 1, all the way to NC minus 1. Sum them up together. Oh, sorry, multiply them together. Multiply each and sum them up together. Okay? Let's see how we can do that. Sum of products. Integer sum 0 4. Let me just call this loop counter here y, because when you refer to the instruction, that the y is the variable I use in the mathematical description. I'm going to call this just y. Okay, y is going to be from 0 up to NC1. Okay, that's exactly the range for y. Let's try this. For y integer, y is assigned to be 0, and then y less than nr2. That should be NC1. and then y plus plus. Okay, we say sum plus equal, and 1, the same row, and something over here, multiply m2, and then something here, and then it should be also c over here, right? Okay. And then after this, we can say n3 r and c is assigned to the sum after that. What should we put in question mark? Well, just y. Okay? Okay, any question about this concept over here? I'm just translating math into Java. Again, the Java syntax itself is not too difficult. It's really about how you can translate from math into Java, right? That's the more important part. I think that's what you should do for assignment 5, test number 1. You should really try to observe when you try to rotate a matrix clockwise, what would be the corresponding relationship between the indices. That's what you should do. Okay, you can try to program out. I think it should work. Any questions before I take a little break, and then we'll move on to objects. Okay, let me stop the recording now.